Hello students, I am Professor Kshitij Yugbodh, Department of Mechanical Engineering, SISTec-Ratibad. Today we are discussing Unit 1 of Renewable Energy Technology, ME 604C 6th semester. Topic 1 of this unit is Solar Radiation, Renewable Source of Energy for Future. So first of all, what is solar radiation? Solar radiation, often called the solar resource, it is a general term for the electromagnetic radiations emitted by the sun. Solar radiation can be captured and turned into useful form of energy such as heat and electricity. Point 3. Solar radiation is a radiant energy emitted by the sun from a nuclear fusion process. Fourth, the spectrum of solar radiation is close to that of a black body with a temperature of about 5800 Kelvin. Half of the radiation is in the visible shortwave part of the electromagnetic spectrum. So it is clear from the definitions that solar radiations are the radiations coming from the sun in electromagnetic waves, and we can use all these waves in different purposes as per our requirement. The main reason of electromagnetic waves is the nuclear fusion process which takes place inside the sun, and in that the hydrogen converted into helium. Basic factors for solar radiations. Because of solar radiations on any particular point depends upon several factors which affect the intensity of the radiations on a particular point. So we are discussing the different factors on which the solar radiation depends. Every location on the earth receives the sunlight at least part of the year. The amount of solar radiation that reaches any one spot on the earth's surface varies according to: the first one is geographic location. Because of on every part of the earth the radiation or the sun rays, it doesn't strike vertically. On some points the rays also strikes slantly. The reason is being the size or shape of the earth. Time of the day. Because of the radiation depends upon the daytime of the day. The maximum intensity will get in the afternoon time, while the least intensity of the radiation will get in evening time or in morning time. Season also depends upon the intensity of the solar. Next is local landscape also affect on solar radiation, and local weather. It also affects on the local weather, which we can see in this diagram. The sun's intensity depends upon the humidity, that is weather, terrains and relief, which is local landscape, altitude, the geographical location of that particular place, air quality, vegetation, and the received insolation on the earth will be this. Now, what is energy conversion? Because of whatever the energy is coming from the sun, we cannot directly use that. There are some processes by which we can use the sun's energy in useful work. So there are three energy conversion processes are normally associated with the sun. The first process is known as heliochemical process. The process which is principally the photosynthesis process by which the plants they use the sun's rays or they use the energy of the sun for their food purpose. The second process is helioelectrical process, which is commonly exploited in solar cell like photovoltaic cell. In this process, we are using the sun's radiation to convert these radiation into electric energy with the help of a photovoltaic cell. The third process, that is heliothermal process, which is a conversion of sunlight into thermal heat, is employed with the concentrated solar power CSP plants in this plant. Now, we'll try to understand the basic terms of solar radiation. The first term is solar constant. So what is solar constant? The solar constant, the total radiation energy received from the sun per unit of time, per unit of area on a theoretical surface perpendicular to the sun rays. So whatever the sun's radiation we are getting perpendicular to the sun rays on the earth, that radiations or that radiation energy is known as solar constant. The solar constant generally accepted by the space community in approximately 1.362 kilowatt per meter square. So it is the value of solar constant for per meter square, and for this the earth is at its mean distance from the sun, and that is 15 crore kilometer. The distance between the sun and the earth should be this. Now the another term, that is solar irradiance. The solar irradiance is the output light energy from the entire disk of the sun measured at the earth. Means whatever the radiations or whatever the energy is coming out from the whole disk of the sun, this is the disk from the sun on the earth, that is known as the solar irradiance. The solar spectral irradiance is measure of the brightness of the entire sun at a wavelength of light. Now, there are basic component of solar irradiance. Because of the brightness and all depends upon the three different factors, and we are discussing them. In this figure we can see there are three different components of the solar irradiance. The first is direct beam. It is directly coming on the collector because there is no intermediary between this. The second is this energy wave is coming here, reflecting, and then only going to the collector. And the third component of this energy rays or waves is scattered through these all obstacles like dust particles or clouds. So there are three basic components to the solar irradiance on a surface. The first is direct beam, which we can see here over here. The second is diffused or scattered, which is here. It is diffused or scattered due to some impurities like dust particles, like cloud particles. The third one is reflected short wavelength radiations from other surfaces, which we can see over here. These waves are coming here, these are reflected, these are also known as terrestrial radiations. So, solar irradiance is the amount of solar energy incident on a surface per unit time, per unit area. So this is also depends upon the whatever the components are there. If there are any impurities or any other objects between the solar radiations, then only but obvious the energy incident on any surface will be less. Now we'll talk about the applications of solar radiation. Because of it is an ample amount, the whole solar system, if we talk about, will get 99% of the energy from the sun in solar system, and we can use this energy for different useful purposes. If we especially talk about the solar radiations, then only we have lot of applications of solar radiations. The first application of the solar radiation is solar water heating. Because of we will talk about the intensity of the sun throughout the year is almost same. So we can use the solar energy to warm the water or to heat the water. So for this purpose we are using solar water heaters. Solar heating of buildings. In some cases where we feel that yes, we want to heat any building, then only we can use this heat the heat of the sun or the solar radiations to heat any building. This heat can be of two types. The heating can be done in two types, the passive heating and active heating. We'll discuss these points in another, say, topic 2. The third is solar distillation. We can use the solar radiations for distillation purpose as well. Solar pumping. So solar pumping is another important application of the solar radiations which are used nowadays. The next is solar drying of agriculture and animal products. Next is solar furnace. Next is solar cooking. And the next is solar electric power generation. The next application of this is solar thermal power production. And the last is solar greenhouse. So by this slide we can see that we can use the solar radiations in different applications. Now we'll talk about the advantages of solar radiation. The solar radiation is a renewable energy source. So among all the benefits to the solar panels, the most important thing is that solar energy is a truly renewable energy source. It can be harnessed in all the areas of the world and is available every day. The second point is reduces electricity bills. Since you will be meeting some of your energy needs with the electricity your solar system has generated, your energy bill drop. The third is diverse application. As we have seen in the application part, the solar energy can be used for diverse purposes. Low maintenance cost. Solar energy systems generally don't require a lot of maintenance. You only need to keep them relatively clean, so cleaning them a couple of times per year will do the job. So this is all about the advantages. Now we'll discuss the disadvantages, because every technology having a positive and negative side. So we'll discuss about the disadvantages of solar radiations. So the first disadvantage of the solar radiation is the cost, because of the initial cost of installing and purchasing of the solar equipments are very high. The second is weather dependent. Although solar energy can still be collected during cloudy and rainy days, the efficiency of the solar system drops. Solar panels are dependent on sunlight to effectively gather solar energy. So it is another disadvantage because it is weather dependent. The third disadvantage is solar energy storage is expensive, because of solar energy has to be used right away, or it can be stored in large batteries. These batteries, used in off-the-grid solar systems, can be charged during the day so that the energy is used at the night. So this is overall another cost is added in the solar energy, and that is the cost of battery, and that is too huge. The fourth is uses a lot of space. The more electricity you want to produce, the more solar panels you will need, as you want to collect as much as sunlight as possible, because of it is directly proportional to the requirement of the energy. If you need more energy, you have to install more panels. So that's why the space required will be more. The last point is associated with pollution. Although the generation of electricity by the solar panels is not producing any pollutants, but while we are manufacturing the solar panels, it creates or will use some harmful products. So that's why it is also associated with pollution. Thank you very much.